Let's do scientific or chemistry vlog for today. Yesterday I did vlog with regards to health, and now let's divert for a little while, for quite somehow, talking about the periodic table of my life. Wow! So it's gonna be like that. Okay. Oh my gosh. Wait. Okay. So the first thing to do. Hello, I'm coming back. Can you see me vividly in the screen or not? Then, if not, I will be able to adjust the screen space or whatever or adjustments that I'll be able to make in order for me to be seen conspicuously. Wow. Okay, things like that. Okay, the title and the caption of this vlog is all about periodic table in my life. Wow. Okay, so like the periodic. Okay, like that. So, young students and pupils take up chemistry up to this point in time. So please let on me, okay, please bear yourself with me and kindly be alerted to this particular topic of periodic table of my life. Okay, so can you see me guys or not? Oh wow, okay, so it's not clear, right? The ink of this marker. So I have now 7 markers, but it looks like all the ink had consumed already because I kept on vlogging every moment of my life here in Riyadh, Kingdom of Saudi Arabia. Okay, so we will do this periodic. So let's just have a capital letters in order for you to see clearly, right? Okay, periodic table. This is your informal professor or informal periodic table. Okay, things like that. Okay, so what you understand about periodic table, class? Anybody? So any idea for this particular topic? So before going in detail for this particular topic, I may introduce the people behind the discovery of this periodic table. So we have the modern and the old periodic table, and we need really to determine who are the people behind the live. Okay, Dmitry Mendeleev. Okay, so as you can notice in the last period of the periodic table, the isolated actinide series and lanthanide series, then kind of look at the last row, there is Mendeleevium. Okay, Mendeleevium is derived from the discovery of Dmitry Mendeleev. He is a Russian chemist. Okay, somewhere along the way in 1869 or 1870 or 18th century to be sure. Okay, because I could not really exactly remember the exact date for that. Okay, so he discovered Mendeleevium. Okay, with an atomic number of 100 and an atomic mass of 257 gram per atom. Okay, so this is the element, okay, belongs to the actinide series, okay, discovered by Dmitry Mendeleev. But apart from that, Dmitry Mendeleev has a great contribution in our periodic table, and in fact, he is called the father of periodic table, okay, in 18th century. Okay, things like that. Okay, so he postulated and he was able to have a postulate regarding that. Okay, elements. Okay, you can take down notes also as well if you want, class. Elements, okay, are arranged, okay, in increasing, okay, atomic masses. Okay, atomic masses or weights. Okay, like that. From top to bottom, from top to bottom. So what we mean here? So this is gonna be the group, close and open parenthesis, group. Okay, and also, okay, from left to right. Also, from left to right. Okay, of the group, right? Okay, things like that. So, Dmitry Mendeleev said or postulated that elements are arranged in increasing atomic masses and weights from top to bottom and also from left to right of the group. Not only that, he said also from top to bottom, from left to right, the physical properties and chemical properties of each element is also arranged properly. So elements in the same group have the same and similar physical and chemical properties. And what are those? Okay, we need to give an example. For example, number one, the electronegativity. Okay, so number two, we have the ionization potential. Okay, like that. Okay. Number three, we have atomic size. That you will be able to talk with the atomic size. We are referring to the radii and the radius. Okay, and the radius. So radii is a diameter. Radii is a synonym term for diameter, sorry, and radius. Okay, number four, with regards to the melting point, okay, boiling point, okay, things like that, no, okay, the molecular weight, okay, like that, okay, things like that. So there's still so many chemical and physical properties, so we cannot enumerate them all. So just try to research by your own selves in the website, or if you have a chemistry textbooks in your hand now, okay, you can refer that also. And if you have also regular classes in chemistry, then you can sometimes also ask your chemistry teacher for you. They will be able to help you passionately, right? Okay, things like that. Okay, so most of the times in examination, they will say which of the following element is not part of the group. So that would mean in terms of their electronegativity, ionization potential, atomic size or diameter radius, melting point, boiling point, molecular weight. Okay, sometimes like that. And sometimes also asking of intermolecular forces acting on each element. Okay, things like that. Because it usually deals with a polarity also. Polarity, okay, non-polarity. Okay, things like that. So the study of polarity versus non-polarity of each element is very important in manufacturing different products all over the world, because we can really determine how conductive to heat, electricity, and for other environmental factors, so we can maintain the quality standards of each product. Of course, if we try to manufacture and produce the products, especially solid materials in the market, then we need to determine what elements, what metals to be used, so that we can chemically bind those elements to produce the desired products that we will be able to sell in the worldwide market. So it's the job of the research and development department in a certain company and a factory, if they have. But if they don't have, so they will be able to entrust this kind of responsibility and commitment to the design engineers of that particular industry. Okay, guys? So this is how relevant and valuable and essential to consider the different physical properties and chemical properties of each element in the periodic table. And now that is from Dmitry Mendeleev. But wait, guys, there is also another guy behind the discovery of this periodic table, in which we can often say that he is really the father of the modern periodic table, things like that. He is Henry Moseley. So what is his contribution all about? Okay, can I erase this content in the whiteboard? Because I have a very minute and small whiteboard, I can really not fully utilize my discussion very well. Limited space, by the way. Okay, guys? Okay, so let's go to Henry Moseley. Okay, Henry Moseley, again in 18th century. So it took Henry Moseley for about, let's say, 50 years after the death of Dmitry Mendeleev. He able to increase, okay, the relevance of these elements in the periodic table, but he really improved. Okay, but sad to say, the credit and merit of being the father of periodic table is given to Dmitry Mendeleev. But of course, this Henry Moseley plays an important contribution because in him we might understand the electronic configuration, which is the basis for electronics industry and semiconductors industry, especially for manufacturing and producing electronic products all over the world. It could be mobile laptops, gadgets, whatever, appliances. So all of them are made up of different elements. Okay, and we need to understand the electronic configuration by further understanding of the electrons shared and unshared. So in that manner, we can really determine and distinguish the polarity versus the non-polarity of the elements. Okay, then of course we are surrounded by different materials inside a room, so definitely and absolutely these are made up of various elements. If you try to dig it deeper, and if we are be able to get a sample in it and analyze that in the laboratory, of course we need to decompose first the materials in order we can arrive to a certain analysis that we could be able to see, oh my gosh, there is silicon in these tiles present by volume, percentage by volume, things like that. So we can do our microscaling analysis in the laboratory for that, for the purpose of, the reliability of the data, physical and chemical data of the particular materials. Wow, unstoppable Jojo Iglesiero, right? Okay, so we have here Henry Moseley. Okay, Henry Moseley postulated that elements are arranged, okay, in increasing atomic number. Okay, increasing atomic number. Okay, and he said also that properties of elements are periodic functions of the atomic number. Okay, so during your memorization technique and in your comprehensive understanding, I advise you not to memorize plainly. So just get the keywords and expand your learning out of that. Then maximize it, okay, by having your own words during your memorization technique. You got a point, so things like that. So your keyword here is atomic number, and then you can arrange that through phrasing and structuring that in a sentence, in a paragraph. Could it be a compound sentence or a complex sentence? Then you can add a lot of adjectives or pronouns or conjunctions or whatever. It depends on you. That is the case if you love English language as a subject. But if you don't love English, it's just okay. You can also memorize plainly, but be sure to understand well what you are memorizing. Right? Okay. So Henry Moseley said that elements are arranged in increasing atomic numbers from top to bottom, from left to right. And he said as well that the properties of elements are arranged in periodic functions of atomic number. So we can clearly distinguish the contribution of each from Henry Moseley and as well as from Dmitry Mendeleev, right? But both of them discovered this, improvements and arrangements of the periodic table somewhere in the Industrial Revolution in 1800s. So this is the start of the Industrial Revolution in which all countries all over the world starts to be industrialized, things like that. And this is also the starting point of the global warming and the climate change all over the world due to gas pollutants, mainly the greenhouse gases, which is specifically the carbon dioxide. So it is after 1800s. And after 1800s also, class, there's a lot of discoveries in science also, as you can notice. I'm not saying that there's no discoveries, 7th century, 16th century, but it is in the 18th century where a lot and enormous and really tremendous discoveries sprouted and evolved at that era. Okay, you get a point? Okay, too much with the history for this periodic table, and we will be able now to go deeper, okay, in the elements in the periodic table. Okay, I may explain this. Okay, right? Okay, now, if you have a periodic table in your hand now, you have, or you don't have. Okay, so when we are in high school, especially or specifically in third year high school, our teachers really pushed us to buy the periodic table, right? In different stores or markets as we wished. Okay, then, we keep on looking at it, alright? Things like that, because nobody wants to memorize the physical and chemical properties of each element, right? So we may not found it useful at that moment at a very young age. Now, if you are taking chemistry, BS chemistry, or Bachelor of Science in Chemistry and Bachelor of Science in Chemical Engineering, then you may say, if you try to return back to time, that it is very useful to comprehensively memorize the properties and chemical properties of each element in the periodic table, right? Okay, my advice is if you really, forecast that you will become a chemical engineer and a chemist in the future, so at your high school era, you need to memorize, okay, at least 80 elements with regards to their physical and chemical properties, okay? So I can say and trust me, you will never regret it for the rest of your life. Okay, now we need to talk about first the different terminologies with regards to the periodic table. So we have the ANU. What is ANU, by the way? So, if you try to look your periodic table, if you take a look and glimpse, well, glimpse is synonym with taking a look, right? Okay, so if you take a look of your periodic table, if you have now, so there's A, N, U. Small letters A, N, U. This is abbreviation or an acronym that says atomic mass unit. Okay, atomic mass unit. Okay, this is for a single element. Single element. Okay, so if I have, let's say, calcium carbonate, the limestone, okay, so I will say atomic mass unit. I could never say atomic mass unit. That is wrong chemistry grammar, because atomic mass unit is intended only for a single element. You get a point? Things like that. For example, silicon, hydrogen, nitrogen. What is the atomic mass unit? So if you can see your periodic table, there's a square, right? And there is an atomic number at the top most. Okay? It's written there. And at the bottom part also, there is a number, right? So, for example, I will consider first Mendelevium. Okay, let's say NV, right? NV. This is the symbol of the chemical element Mendelevium. It's very difficult, right? Mendelevium. Okay, this is having an atomic number of 100. Okay, so the atomic number class is in the top. Okay, like this. Okay, and the mass number is in the bottom. Okay, the mass number is also the atomic mass unit of a single element. So for example, Mendelevium atomic mass is 257. So 257 is the AMU of Mendelevium atomic mass unit. At the same time, this is also the mass number of Mendelevium. At the same time, this is the atomic mass. Okay, or atomic weight. Now, can we use interchangeably the terms AMU, mass number, and atomic mass and weight? We can't. But we can use interchangeably the AMU and the mass number. Okay, things like that. Okay, but atomic mass, atomic weight, the only difference, it has a unit of measurement, which is the gram per atom. Okay, so if I will say, what is the atomic mass and atomic weight of mendelevium? Okay, you will still say also 257, but with a unit, gram per atom. Now class, if I will ask you, what is the atomic mass unit of mendelevium? You will never say 257 gram per atom, but you will say 257 only. So meaning to say, atomic mass unit and mass number has no unit. So the only drawback and the only gray area, gray, G-R-E-Y, meaning confusing part, okay, in English language. So you need also to practice synonyms, right? So that we can really understand the synonyming and the same meaning in the same words or whatever. You get the point? So you need to maximize your English language as well. Okay, so if we have here atomic mass unit. So, oh my gosh, the word unit here is very confusing. Okay, things like that. Why it is atomic mass unit? Then you will say, Sotero or sir, that has no unit. Okay, the unit here is not word for word in understanding. Okay, the unit here is simply the unit it says in English term. It's not the unit of measurement it means. Because there are words in English language that the same spelling, okay, but it has not the same meaning. You get the point? So it depends on the context where you are using. So you don't mix them together in phrasing, in structuring, in your sentence and paragraph. If you write a letter, if you write an article, for example, only if you're a writer and an author, things like that, in your public school paper and you are in the journalism department, then you need not to mix up the same words, the same letter with the same meaning all throughout. Okay, get the point? Things like that. Okay, these are what we call homonyms. Okay, homonyms, meaning to say the same spelling but different in meaning in this context of discussing between AMU and atomic mass and atomic weight. Because I said a while ago, when you say atomic mass unit, there's no unit. So maybe you will be confused. The unit there means unit of measurement. Okay, right? Okay, to make this with clarity. Okay, class? Okay, things like that. Any questions so far? Nothing, right? Okay. So because this is a very virtual platform in discussion, of course there's no question. I need to see the screen now if I have the viewers. Oh, they are hiding. They don't like chemistry. Oh my gosh. Okay. To those chemistry lovers and science lovers only, by the way. Okay. So, now, I said a while ago that we need to have at least 70 to 80 elements, right, to remember about their atomic masses and atomic weights. Now, we need to enumerate and list them all in no particular order. Okay, for example, if I will, but before that, we need to classify the different types and the classification and categories. So, in a periodic table. So, let's do this by grouping or by group, not by period. Right? Things like that. So, by group lang, no? Okay, say things like that. So, group 1A. So, group 1A is the first column from the left in your periodic table. This is called alkali metals. Okay, things like that. We are now in the categorization of different elements. Okay? Things like that. Number 2, group 2A. Okay, group 2A. This is called alkaline earth metals. Okay, things like that. Earth, meaning the sound with extra earth. Okay, earth, no good. The pronunciation is bad. Earth. Okay, alkaline earth metals. Okay, pronunciation and phonetics. Okay, things like that. Okay, I need really to enunciate word. Things like that. Okay, this can improve our diction. and pronunciation, especially if you're using English language as our medium of instruction during vlogs. Though it sounds minor only for others, but to those who are very particular for the fluency of any individual in the social media world, then this matters a lot, right? Okay, so alkaline earth metals. Okay, things like that. Okay, please forgive me, okay? This is my style. Number 3. What else? So we have the transition elements. Transition. What do you mean by transition in English? The word transition. Okay, meaning it could easily be shifted from one state to another state or one phase to another phase. So, for example, Jun have a transition of his profession from chemical engineer to safety engineer. So, meaning a sudden shift or a quick shift if you want by changing, by shifting, things like that. It is transition. You get the point? So, if you try to put that in the context of periodic table, meaning to say, these elements would try to act sometimes as a liquid, sometimes as a solid, sometimes as a gas. It depends on the operating conditions based on their extrinsic properties. What do you mean by extrinsic properties? Those are physical properties. For example, temperature, pressure, things like that. Boiling point, melting point, freezing point, viscosity, like that, or surface tension, specific gravity. So these are all physical properties, specifically extrinsic properties, if we try to refer in chemistry, and these are also called extensive properties if we deal with material science subject. Am I correct? Or the reverse, or sorry, it's the reverse. Extensive property in chemistry and extrinsic properties in material science subject. Okay, but basically the same point of view, right? Okay, transition elements. So this is from 3A Charus. Okay, so we have here 3A up to 2B. Okay, things like that. You can take a look at the periodic table. If I am mistake or I am having an error, then you can correct me also. Guys, because I had been finished with chemistry 30 years ago. Okay, so I could not expect, you also cannot expect me to do the vlog or discussion perfection or at its finest. I can only deliver the discussion based on my capacity to do it. Okay, number 4. Okay, we have here also the BCNOF. Okay, what this all about, Sir Sotero? BCNOF. But we need to terminate the F because F has a special group or family. Okay, B is the boron family, C is the carbon family, N is the nitrogen family, and oxygen is an oxygen family. The technique here in your memorization, the topmost element carries the flag of those particular elements in a group. So if boron is in the top, you will say boron family. Okay, so since carbon is in the top also, it is also carbon family. But to be specific, this is boron is 4A, carbon is 3A, 3A, 4A is carbon, 5A is nitrogen, 6A is oxygen. Now I drop out the fluorine because they have a special family, which is a halogen family. Okay, or what we call sometimes as a halide group. Okay, things like that. Okay, halogen family or halogen group. Okay, so family and group in a periodic table means the same. Again, family and group in periodic table means the same. That means the column, okay, from column 1 to column 18, because we have 18 columns in our periodic table. And the last column will be the noble gases. Later on, we will explain that also. Okay, things like that. Now, 3A for boron family, 4A for carbon family, 5A for nitrogen family, and 6A for oxygen family. Okay, these 3, 4, 5, 6 are very important because this would represent your valence electrons in the outermost shell. in each element, especially if you do the electronic configuration of each element, things like that. And this could also the basis of your covalent bonding when you try to designate the sharing of electrons during the covalent chemical bonding of each element to become a compound later on, things like that. So we are referring here electrons, valence electrons specifically. Okay, things like that. So if we mean valence, these are the electrons in the outermost shell. Because if we can remember the Bohr's theory, Neil Bohr's theory, okay, and the John Dalton theory of atomic theories, right? So if we have the atom, single atom, right, like that, and we have the nucleus on the center, nucleus, right? If you can still remember that. So we have two shells. One, two. This is an inner shell. English also matter. Inner shell. Because this is the shell inside. That's why inner. Okay, inner shell. This is outer shell. Right? Okay, I may discuss this in English context point of view. Outer shell. Now, I said in my grammar that outermost shell. Why I put most instead of outer only? Because it depends on your reference. Because for example, if I have 4 shells here, okay, then this is my inner shell. Then I could say the second shell as my outer shell from inner shell. But this is not my outermost shell. My outermost shell is the last shell. Okay, in English language, this is the last outer shell, most, outermost. But within that shells, there's also outer shells with the reference in which you are referring to. You get the point? For example, if you have shells 4, 1, 2, 3, 4. My outermost shell is the 4. Then I could say also my outer shell 2 from reference of inner shell 1. That is outer shell, but not outermost shell. So this is the difference how to use the grammar in the discussion of saying in this particular context. Okay, so that we can understand really the outermost valence electrons. So meaning to say, these valence electrons are not the electrons in the second shell, third shell. These are the electrons occupying in the outermost shell. Okay, students, let's have a clarity. So we will not mix up the grammar in chemistry saying that's the valence electrons. Hey, that is not the valence electrons because that is in the second shell and we have 4 shells. That's only an electrons, but not the valence electrons. Okay, now we need to distinguish between electrons and valence electrons. Okay, for clarity, electrons are those electrons within the shells of the nucleus, okay, in an atom. The valence electrons are the electrons in the last or the outermost shell of an atom, okay, and that is exactly what we mean in chemistry as valence electrons. So don't mix up the definition so that we can understand really if we try to go with the electron dot structures in the chemical bonding, non-polar or polar covalent chemical bonding in the Lewis theory of basicity and acidity. Okay, things like that. So if you really love chemistry so that you can protect the exact and precise chemical products during your chemical equations, we need to understand the 3 theories of Arrhenius theory, Bronsted-Lowry theory, and Lewis theory. In that, you can perfectly obtain the desired chemical products as you wish if you have the basic foundation of these 3 theories. Okay, so my suggestion is you need to focus with the concept. Okay, you need to focus with the theorem because equations and formulas will be later. That's the part to justify, to validate the theories discovered by the different scientists in the past. Okay, so we need to go back to the basic foundation and concepts so that we can really understand how to solve properly mathematical problems linked to science. You get a point? So it's not all about solving like this without understanding, and you're only copying how it is being solved. You remember how it is being solved and memorize the steps. No, it's not like that. We need to understand really the basic foundation, the concept behind and the rules, why it's going to be like that, where this comes from. So that it is very easy for us to derive an equation as we wish, even though to the extent that our teachers did not teach us that. Because we cannot really depend on our teachers also. Okay, so this is us. Okay, we are the responsible person to increase our knowledge. They are just an instrument, right? Things like that. You get the point? Ganon. So, halogen family na ta mga palangga kong hitad, no? So, halogen family is fluorine, chlorine, bromine, iodine, astatine. Okay. 6 category, we have the noble gases. And now let's explain this with clarity. Okay. So, noble gases. Okay, what are those noble gases? Okay, what do you understand with the word noble? I will say, teacher is a noble task, a noble profession, and generally we could say it is the noblest task or profession all over the world to become a teacher, because shaping the young minds of our young generation, okay, it can change the world for a better place to live, because we adults will just pass in this contemporary world. They will replace our crown, or they will replace our throne, our era. So we'll never stay. Okay, so nobody will stay in this planet Earth. We will entrust this to our young children. So that's why our teachers really shaping the young minds of our future generation, because these children are the leaders for their own countries and to make the world go round a better place to live, right? So, oh my gosh, how marvelous is this notion and concept? Okay, yes, of course, right? Okay, so noble means really ideal, like that. Meaning to say, almost perfection. That's what we say, I will find my ideal woman, things like that. So meaning almost perfection that meets the criteria of what you really want, of what you really like. So as much as you could, because that will be your partner for the rest of your life, and you have to choose of billions of women all over the world. So that's ideal woman. So we speak of ideal or ideality that is close to perfection. Okay, that's also noble. Okay, meaning to say almost perfection. So once it is almost perfection, so that is really noble. Meaning you are stable. Okay, so if you are stable, would you try to react to anybody else if you are financially secure? You have all the money all over the world, then of course you will never work anymore because you are stable. You have investments. Your house is a 4-story building like that. You have a new sports car, a very fancy and expensive sports car like that. You have a very renowned and popular business in which it is highly distinguished and known all over the world. Then how can you work bad? You are stable already. So gases also like that, stable. They don't react anymore. So that is the purpose of our noble gases: neon, xenon, argon, krypton, radon. So these gases will never be chemically combined to any elements in the periodic table. Trust me. You can never encounter xenon dioxide. You can never encounter neon chloride. You can never encounter krypton oxide. Nothing. Okay. Because they don't react chemically. They don't chemically combine to another elements because they are stable, meaning and reactive, not reactive. Okay, things like that. So that's the clarity how we say noble gases. Okay, things like that. And it's very clear now, no? Noble gases. Okay, that's number 6. Number 7. We have also the last two rows in our periodic table, the actinide series and the lanthanide series. Lanthanide series, okay, and actinide series. Actinide, ha? Okay, actinide series. Okay, the actinide series is the last row or the last period in the periodic table. So, what we mean by row in our periodic table, this is called period. Okay. If I will say, could you identify Junjun? What is the particular period of sodium? So you will based on the row, not on the column. You get the point? So, meaning to say, a period is not a group, it's not a family. Okay, it's a row. Things like that. You get the point? And now, what is the purpose and intention of the row in periodic table? This is very important in electronic configuration because we can determine how many number of levels or energy levels, shells like that, or orbits in your atom. Okay, so if I have I have four shells, if I have four orbits, okay, like orbits in which the electrons will surround there, okay, or shell, meaning to say shell, orbit, energy level are just synonyms with each other. So during examination, don't be confused because sometimes this is a trap and a trick for a questionnaire that they will use the term in which the students and examiners are not familiar with. You get the point? This is really to measure our comprehension. If we maximize the terminology in our understanding. You get the point? So that's why it's in here that English language matters a lot. Okay, so shell, level, energy level, things like that. These are all the same. So these are representing the period in our periodic table, the row, things like that. For example, if the examination will say, which of the following is not belong to the period? So you can understand now. A, B, C, D. So ma-perfect ka in terms of periodic table examination. If you're just listening to me right now. You get the point? Things like that. Now, which of the following is not belong to the group? Which of the following is not a noble gas? Then, a perfect sa theory examination. Okay, you get the point? Things like that. So, I can guarantee the theories for the physical and chemical principles. But I cannot guarantee the complexity of the problem solving. Okay, because I am on the basic foundation talaga, guys. You get the point? So, I really suggest go back to the basic foundation. Just like building a bridge. If your foundation is not strong, it will collapse. If earthquake will come, strong wind will come, or if there are overloading of the bridge, okay, beyond the capacity of that particular bridge. So students, examiners, or individual are also like that. We need to have our academic foundation in order for us to easily pass different examinations, whether difficult or easy or average round examination. You get the point? Things like that. Any questions so far? Okay, going back to item number 7, we have the lanthanide series and we have also the actinide series. In our lanthanide series, we have, okay, atomic number from 57 to 101. Actinide series, atomic numbers from, okay, 89 to 103. Things like that. Okay, again, lanthanide series, sorry. Okay, my neurons fails quickly and now I catch up. Lanthanide series from atomic numbers of 57 to 71. Okay, because my brain really corrected immediately. How come 100 and I still have the actinide series? So you can easily correct this if you know what you are doing. If you love what you are doing, if you're enjoying what you are doing, if you really understand what you're talking about, you can easily correct that. You just not let that pass. You get the point? Things like that. Because nobody is perfect in this contemporary world. Okay, going back to actinide series, we have 89 to 103. So these are atomic numbers. Okay, I will say an atomic number of 58, blah blah blah, so and so. What is this element? So you will focus now to lanthanide series only for easy determination. Do not be bothered with the other elements with atomic numbers below 57 and atomic numbers beyond 71 because it's clearly stated in my explanation today or at this moment. Okay, now actinide series 89 to 103 atomic numbers. If the question will say, it's an element that has an atomic number of 90, blah, 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 so and so, like that. And then don't be bothered with other elements that have atomic numbers less than 89 and beyond 103 also for the actinide series. Okay, so this might be a technique so that you will never be lost if the examinations in chemistry will focus on periodic table. Because to tell you honestly, there is always like that in science examination, talking about elements. The most common question is the symbol, asking for a symbol. Okay, but they will try to treat as a symbol that is not really very easy to detect. For example, the symbol of tungsten. What is the symbol of tungsten? And the first letter of tungsten is the capital T. But not all elements that the first letter of the word of the particular element will represent the symbol of the element. So, though a lot of it will represent, but others are not. Example to this is tungsten. It is capital W, the chemical symbol of tungsten. And W is very far from T. You get the point? So, during our memorization technique, so we need to understand, oh my gosh, things like that, okay? And you can note that in your hippocampus part of your brain cells, so that you can really engrave, implant, and inculcate that somewhere along the way in the pool of your knowledge and learning in that particular part of your central nervous system, which is the brain. Okay, things like that. In our anatomy study, right? In central nervous system. Okay, muna siya. Actinide series. Okay. Now, I cannot show to you the metalloids because the metalloids, for example, germanium, silicon, polonium, arsenic. So these are metalloids. Okay. The same characteristic with transition, but you know, this is not very easy for them to act as a gas, as a liquid. It depends on whatever artificial energy you will be able to put into. What artificial I mean? You're going to heat, you're going to boil, you're going to decompose, things like that. A person needs to do something, an action, in order for that to change the properties or to change the phase. These are all artificial. That's why artificially prepared elements like that. Okay, meaning this is not natural. So that's what it means. Okay? You get the point? So, di na ako i-appeal ang mga metalloids. But metalloids are always mixed to the non-metal side. Okay? In the periodic table, guys, the more you will go to the right, the more the elements will become non-metals. Okay? That's why they are mostly electronegative in nature. What do you mean by electronegative in nature? Meaning, they are very, very hungry to receive electrons in order for them to be stable. Okay? Because all elements there are really dream also to become stable, just like the human being. All of us dream to become stable. That's why we are working for our investment, to have business and to go back after 60 years old in our country of origin to establish business or whatever we're going to do for good in our own respective country, things like that. Elements are also like that. They dream to be stable, and these are all electronegative elements in the right part, and mostly of them are non-metals or the gases, but the metalloids are mixing there. Okay, as I told you, germanium, silicon, polonium, arsenic. So that's why I don't put, because it will mix up in our understanding. Just leave that there as long as you have an idea that metalloids are mostly used in semiconductors industry or electronics industry. For example, if you are making cell phones, mobile phones, laptops, appliances. So if you can try to look in the inner parts or components of a particular appliance or technology or whatever, then there's a PCB, printed circuit boards, for that. And that is really the life of the technology and the appliance and the machine. Just like where the circuitry or the circuits are there. Okay? That is printed circuit boards or PCB. Without this PCB, this technology and appliance will not function. This is also the, the internal system of our body, just like the central nervous system, excretory system, digestive system, circulatory system, the cardiovascular system, the digestive system, the respiratory system, the appliance, technology, laptop, mobile phone. If you try to disassemble that also, you can see the printed circuit boards. And that's the life of those appliances and technology. So that's why during repair, they will open that and check it out what happens to the circuits inside this particular gadgets or whatever. You get a point? Things like that. So that's why. Okay, so we are now having 8 lang, no? So alkali metals, alkaline earth metals, transition elements, the BCNO group and families, groups and families, halogen family or halogen group or halide group or halide family. Okay, noble gases or the unreactive gases, which is the group 0 that would represent the column number 18 in the periodic table. Our column number 1 starts from the left and it will go to the right, meaning to say the last column is the column number 18, which is also the group 0 in the periodic table. So we don't call them as a group 8A. If we try to count that, we may say also group 8A because that's after group 7A. But as a rule, we'll never say that. We will say group 0. Okay, the group 0 or the family 0 are the noble and the unreactive gases, which are neon, xenon, krypton, argon, radon, things like that. Okay, now lanthanide series, atomic numbers from 57 to 71. So these are all artificially prepared elements, meaning to say not naturally occurring elements. Okay, so they are doing something to do these elements, meaning they really made by human being. Okay, things like that. Actinide series also artificially prepared. Okay, from 89 to 103 atomic numbers. But both number 7 and number 8, lanthanide series and actinide series, most of their elements are radioactive elements. Radioactive elements has a very high radiation process. Okay, so very dangerous to the health. Okay, this 7 and 8. So for example, okay, iridium, uranium, things like that. Okay, polonium. Okay, so these are all radioactive elements. Okay. Now, in the lanthanide series and actinide series from 57 to 103, in the last 2 rows in our periodic table, as I said a while ago, these are all mostly artificially prepared elements. Okay, out of it, there are 2 naturally occurring radioactive materials. We have only the 2. Memorize this. Maybe it will come out in the examination. There are thorium only and uranium. Uranium and thorium are the only exemption as a naturally occurring elements in the lanthanide series and actinide series in our periodic table. You get the point. That's why in our classification or periodic table, there are 118 elements. Okay, you got that? And the last element discovered is the atomic number 118, that is ununoctium. Okay, that is ununoctium discovered in Russia. Okay, things like that in 2012. Things like that. So that's the last, okay, element. But other than that, there's nothing. But there's hypothetical element. But it's still under question in the United Nations group of scientists that they will never consider that first until it will be proven to be exact, reliable, and there's no subject for any debates. Okay, until now, they are discovering that, especially the Japan people, the Japan scientists are very active to develop 119 above because their laboratory is very, world-class and state-of-the-art, and their government are really supporting for their new scientists because they try to shift to this because they have a lot of technology there, so they need to reach the chemistry as well, not only in the mechanical technology like that, machines and equipments in which they are considered as a top producer of cars all over the world, things like that. So they try to be versatile and flexible to reach also other industry. That's why they started also to discover elements. Okay, so from 2018 to up to now, 2023. And there's also latest, a lot of elements, for example, unonium, so unibillium like that. I will not discuss that first until it will be fully developed. Okay, things like that. But if we try to go back our elements, Japanese also is very, very proud because out of 118 elements, there is only one element there discovered by the Japanese person. Okay, Japanese person, Mr. Yusoki, okay, Morita, in a Riken laboratory somewhere in December 30, 2005. That is nihonium. So nihonium is the only element in the periodic table discovered by an Asian country. Again, there is only one element all over the world discovered by an Asian person. It happens in Japan. The element is nihonium with atomic number of 113 and with atomic mass of 286. And take note, this is very radioactive of a half-life of 10 seconds. Imagine how active is this. You get the point? Things like that. So they are very, very proud that all over the world, they are the only country in Asia that developed one single element under the banner of Japan. Because most of them are from Russia, okay, from America, Germany, France. That's why we have Franchon. Okay, that's why we have also Americhon, America, things like that. Okay, Russian people, Mendeleev is a Russian chemist, things like that. Okay, so proud. The Asian people are proud because of this discovery. Though the only science professionals are taking into account of this because it depends on the course we love, right? Other people don't love science. Other people love sports. Other people love numbers. Other people love accountancy. Other people love nutrition. Other people don't love science. So it depends on the person who knows this. Okay, since I love science that much, I try to research a lot because I'm a licensed chemical engineer and it's very easy for me to impart and share the knowledge all about science, right? Any questions so far with my English language? Okay, though it's very fast or not? Okay, so if there's no clarity, then I'll be able to slow down my speaking skills or my communication skills, right? Okay, so that's why I always teach you guys to be balanced in your intelligence, both written and oral, because oral intelligence is very, very important in the real world. Okay, especially facing world-class companies during the interview. And sometimes, not really sometimes, most of the times, you will stand out from the rest because you have a very clear enunciation and answers for the particular question, and then it's very good to listen if you're eloquent, right? If you have the fluency in dealing with English communication skills, things like that. But this skills is not on the spot and very quick. It has to do something from your younger years that you will develop this, okay? And it's only few who can do this, to be honest with you guys. Okay, but I'm just using this English language as my medium of instruction because I am comfortable in speaking English, even though I am a Bisaya from Cebu and I am a Filipino, supposedly I will talk in Tagalog and Bisaya, but I'm really comfortable speaking English, that's why. Okay, you can interpret there in a wish. I don't care, I don't be bothered. Because most of the time, especially my detractors, my bashers, will always say, oh, this guy is always talking in English. And they will say, arrogant, garaon, like that. No, it's not. This is me. Okay? You cannot alter my personality. This is me. Okay? I don't care. You get the point? IDC. I don't care. Okay? As long as I love to speak in English in my vlogs. Just like you are doing the Bisaya vlogging. Did I interfere you also? No, because you love it. If you love it, then continue. That's your passion in doing the vlogging. But in my case, I do this because I have also friends and viewers all over the world. I have Taiwanese friends. I have other nationalities friends so that they can easily understand also what I'm talking in my vlogs. Okay? Then to be honest with you, it can also increase quite a while my revenues in my YouTube content, right? Okay, things like that. Okay, and I want you to say, please respect. Okay, things like that. Maybe others don't like because I keep on talking in English. Okay, very talkative, right? And very conversant. Okay, I have here 8 formulas or groups in the periodic table. Now, let's go to individual element talking about their atomic masses and atomic weight. Okay, but before that, I need to discuss the basics first, no? So, terminology, so that it will help us also in different examinations. So most of the times, this will be question like that. Okay, what is an isotope? Okay, isotope. Okay, what is a half-life? Okay, like that. You get the point? What is an allotrope? Okay, things like that. What are isomers? What are enantiomers? Okay, like that. You get the point? Things like that. So let's limit only up to 5. Actually, there's a lot, but I cannot think at this moment in time. Okay? Because my vlog is really on the spot. Okay, so let's say isotope. What is isotope? Okay, things like that. Isotope are elements having the same number of protons, okay, or the same number of atomic numbers, but different in mass numbers. Because protons, okay, and atomic numbers are just the same. If you take a look in the periodic table, again, the atomic number would represent the number of protons in your periodic table. Now, why we will consider also that as an electrons? Electrons have negative sign, okay, because it says in the theory, based on John Dalton atomic theory, things like that, that an atom, okay, is a single element. Let's say chlorine, that is one atom of chlorine. So meaning to say, that is composed of a single atom, contains or consists of different mass number, okay, and the same, okay, atomic number. Okay, things like that. You get the point? So how can we rephrase it? Okay, an element is composed of a single atom, okay, that consists of the same number of protons or atomic number and also electrons. Then, regardless with signs. We don't take into account the negative signs there. When you do the electronic configuration, you don't remember the negative sign of an electrons, because in the theory, the same with proton consists the same number of electrons and protons. That's why we will always use electrons. We will never say protonic industry. We will never say protonic gadget. We will always say electronic gadget, electronic industry. We will never say also protons flow in the wire or in the path to produce electricity. We always say electrons flow from the path and wire to produce electricity. But if you try to account, they have the same magnitude or number, numerical, okay, but the same different sign only. You get the point? So muna siya hinungdan, that's why I always use the word electronics. Okay, electronics industry. Electronic, because that's based on electronic configuration. That's electrons. So all elements have electrons. Okay, but there are only types. Okay, this will come out also in the examination, because some teachers will not say this. Okay, all elements, okay, are having electrons. Okay, there are 2 types. What are the types? So these are electropositive, okay, and electronegative. Okay, try to look with these terminologies. What is common denominator for them? It's the electron, right? Then why I put the term electron, where in fact this is positive. Okay, so meaning to say, we are not focusing on the signs, the positive and negative. We are focusing on the existence, the amount, the number of this particular elementary particle within the nucleus. Things like that. You get the point? Okay, so electropositive are all metals. Electronegative are all non-metals. Now, since non-metals are electronegative, then they are very hungry to receive 4 electrons. So, the metals will share, donate, and give their electrons to the electronegative elements, which are non-metals. Okay. So, meaning to say, during the electronegativity reaction, the electropositive elements will become a little bit electronegative because they share and they donate their electrons to the hungry non-metals or the gases. Okay, things like that. So most of the products are a unique compound. Things like that. A unique compound. So like that. This is the reaction of metal and non-metal. Okay, things like that. Metal to metal is another chemical bond, but it's rare. It's always non-metal and non-metal. Okay, you can never say magnesium sodium. Do you see like that is a compound? Tell me honestly. You see that in the book, let's say for example, silicon magnesium. This is metal to metal, right? Meaning to say, it looks like rare or it's impossible. If there is, I could not say also because I'm not researching everything. This is only basing on my concept. Okay, then if you can show me, then I will believe. Is there metal and metal reaction? Let's say iron plus zinc is equals to zinc iron. It's possible in alloying process, but this is not a term compound. This is alloying process to yield a certain product like galvanized iron sheet. You need to react the copper, the zinc, like that. Okay, but this is another thing. This is not chemical reaction. This is process chemical reaction, but this is not yielding a compound. You don't never say zinc iron, copper nickel. No, it's not. You will say a mixture of copper and nickel. You need to put that in a phrase. A combination of nickel and zinc. An alloy of copper and zinc. You need to add description. But you never say copper zinc, zinc aluminum. So that's chemistry, wrong grammar. You get the point? So you will never do that. Okay, things like that. So it looks like not possible. Always metal and non-metal or non-metal and non-metal. Okay, non-metal and non-metal are, okay, molecular compound. Non-metal and metal are a unique compound. So these are the types of compounds according to chemical bonding and chemical reaction. If the question in the future will say, what are the 2 types of compounds based on chemical changes or chemical reaction or chemical bonding? So your answer will be a unique compound and molecular compound. Then if we try to modify the question, what are the 2 types of compounds? There's no additional statements. Your answer will be inorganic compound and organic compound. You get the point? It depends on how the question is being phrased. Then if you will answer inorganic compound, organic compound to the former, then problem. You get the point because it's not true. The answer will be a unique compound and molecular compound because I am saying based on chemical reactions and chemical bonding. So it should be a unique compound and molecular compound. So we need to understand this because there's a lot of chemical reaction. It's easy for you to do the reduction and oxidation chemical reaction. Then guys, it's an advantage really. You get the point? Trust me. You get the point? But if you're not doing this, I don't think so. But be sure you are good in whole math. Okay? But if you're not very good in the whole math, and you are lesser in theories, concepts, you will never pass chemical engineer's licensure examination. Sorry to say that, okay? You need to build basic foundation in science. That's why starting from your elementary, high school, you will never depend only in college. It's okay also if you're really intelligent, but majority of the people are not intelligent by default. Only average. right? God really created human being, not all smart, not all brilliant. It's only for the selected few, right? Average like me, average, things like that, for example. Okay, then don't tell me I can know everything. No, I don't. I don't know everything. That's why I'm studying. I'm researching. Okay, then always mixing this with my stock knowledge and acquired knowledge, of course. Because the point, things like that. Okay, ganun siya guys, ha? Okay, now number 2, half-life. Half-life is the time or period of each element to decay for the particular time. They will decay and decompose to particular certain time, but in a natural process of decaying or decomposing. You don't apply anything, you don't heat it, you don't broken it to other physical separation processes. It's just natural. So that what it means of a half-life of each element, or sometimes a compound, things like that. For example, what is the half-life of a graphite or an anthracite? The allotrope of carbon-12, because we have also carbon-12, carbon-13, carbon-14, because carbon is not really that stable all the time. It will exist as a diamond, sometimes also the precious stone all over the world. Diamond is made up of carbon atoms. You get the point? This is an allotrope of a carbon, just like the graphite, anthracite. And sometimes also it can be also transformed into like bitumen or the asphalt, the black color in asphalting the road. Most of them are composed of carbon atoms because originally and naturally carbon atoms are black particles. Just like when you burn the sugar, there's a black particles. You burn the sucrose, okay, the table sugar or the white sugar, it will produce a black particle. So that is really the natural occurrence or appearance of your sugar. Okay, things like that. So that's half-life. And now we go to the allotrope. What do you mean by allotrope? Because sometimes there's a question also, which of the following is an allotrope of carbon? A, B, C. In the terminology, first, you don't understand what is allotrope, right? So you should have a very wide, synonyms in your brain cells so that you can really answer. You know the point? So this is the faida. This is the benefit of being a wide reader like that, resourceful, initiative, that you spare your time also in a continuous studying and learning rather than for shallow thing. I'm not saying also to stop that, but you need to be balanced. Things like that. You get the point? So always balancing equation in your life to establish the state of dynamic equilibrium in science. You get the point? So everything will be obeying the law of conservation of energy, okay, or the law of conservation of matter in chemistry. You get the point? Things like that. As our father of modern chemistry spoke, Mr. Anton Lavoisier, okay, the father of modern chemistry, that everything will be under the state of in an equilibrium. Okay, so we need to establish the law of conservation of matter. Things like that. You get the point? Because the human being is surrounded with matter, M-A-T-T-E-R. Because anything that has mass, okay, and everything that occupies space and has mass is a matter. For example, I'm holding my eraser, my microphone stand, the tiles, everything in my kitchen is called matter. Because anything that occupies space and has mass is a matter. Okay, refrigerator, laptop, eggs. So meaning to say, we cannot survive without matter. Am I correct? So, how can we drive the car? Things like that, if there's no matter. Things like that. So, if there's no road, problem. So, your car will float somewhere else and there's no gravity. And there's a gravity problem. So things like this, to become an engineer also, you need to be imaginative. Things like that, meaning you have wild imagination. Things like that, okay? If there's like this, you need to expand pa more. Things like this. Well, if you solve sample problem like this, and then I need to see another question or possibility. So you need to sometimes, sorry to say this, you need to sometimes to complicate it in order for you to learn another thing. things like that. So you will never stop, digging, searching, like that, the possibilities, like that, and the benefit of a doubt, like that, okay? You should not be limited in your understanding. You should maximize always to the highest level. Wow! Sorry guys. To the highest level, okay, things like that. Di ba naman, Jude? Aim high always in your life. So it is applicable for every equation in our life, right? To adjust to the different environment, to respond to any stimuli in our ecology. We need to be balanced all the time, right? The equation of our life, things like that. So the only way to maintain that is continuous knowledge through experience, because experience is the best teacher, and also really digging yourself to different topics that are really available online. And then you don't need also to forget all your education knowledge, okay, in your younger days, okay, things like that, okay. So that we are very, very proud from our offspring and our hereditary traits, our genes in our family history, things like that. Okay, got the point. Okay, now we'll go to allotrope. Okay, allotrope is the same elements but exist in this different forms. Okay, the same elements but exist in the same form. So once it is in a different form, it has different name. Okay, for example, I will say the carbon, graphite, diamond, anthracite, like that. But these are all carbon atoms, but they have different names. That's why the same elements, but different in forms. Okay, it could be a solid, it could be a liquid, it could be a gas. Okay, things like that. Blank is an allotrope of this. Blank is an allotrope of this, meaning that is talking for the form or the state or the appearance. It has not to do something with the electrons, atoms, protons, like that. Okay? That's allotrope. Okay, now isomers. What do you call an isomers? Isomers, okay, have the same general formula or chemical formula, but differs in their application, purpose, intent, and also differs in their structural formulation. Also, pero a very lengthy definition. So how can we make it short? So let's rephrase the sentence. So it's going to be like isomers, okay, elements that have the same general formula but differs in their application and structural orientation. So what does it mean? Okay, for example, glucose. Okay, glucose, dextrose, sorbitol. Okay, what else? There's a lot. I think so. There's a lot in my mind, but I cannot express. Okay, so dextrose, sorbitol, glucose are the same chemical formula, general chemical formula. But sometimes also they have the same, but majority differs or meaning different application, like that. Example, sorbitol used as a sugar additive in different beverage drinks to make it sweet, like that. Now, dextrose used in the patient, okay, to let the patient survive their energy for a month, 2 months. So dextrose must be injected to the patient to add, the nutrients can function very well, and also to add oxygen level so that they can breathe properly, because dextrose have 6 atoms of oxygen. So it will help a lot to make this patient inhale, things like that, providing that this patient also have enough minerals, vitamins, and nutrients while they are staying in the hospital. Okay, the moment that the doctor will not give oxygen cylinder, meaning the oxygen level of the patient is still enough to compensate the breathing and inhalation. But the moment The doctor will give oxygen cylinder. It has to do something, the lack of oxygen now in your blood and respiratory, things like that. That's why they will have the dextrose. You get the point? So that's the function of dextrose. The glucose is another function that is for our blood sugar and also for the different manufacture of our carbohydrates like that for our energy. Because glucose is the basic unit of carbohydrates family. You get the point? This is the basic substance in order for us to gain energy in a daily basis coming from ATP, adenosine triphosphate, during the natural reaction of the photosynthesis. Okay, things like that. And then this can be obtained through the chlorophyll of each plant, and in there's a chemical reaction from the photosynthesis, from the energy, the light of the sun, and then it will have a phosphorylation chemical reaction to produce phosphorus. Then after that, it will become an ATP. And then ATP will break down into glucoses. Okay? And then produce carbon dioxide and water. The carbon dioxide will go to the plants. Okay? And the water will go to the soil, like that, blah, blah, so on. So, and the glucose we will try to get that in our food for our energy. And then the CO2 also will split again to oxygen in the atmosphere. Then we inhale that again also. And then exhale that again. The plants will receive as a CO2. This is a cycle process in cellular biology. Okay, cellular biology. Okay, we have photosynthesis, blah, blah, blah. Okay, so cyclic process of that particular citric acid cycle or the Krebs cycle. So biology is not our topic for today. So it's chemistry. So we don't talk a lot about biology, right? So that is isomers. Okay, what is an enantiomers? Okay, an enantiomers, okay, elements or compounds that have the same general formula but different in their image mirror appearance. Image mirror appearance, meaning the opposite. For example, if you face in the mirror, you have opposite direction, right? So the enantiomer substances are like this also. The reverse image of that particular element or compounds under question, things like that. Under question meaning sometimes also they don't have enantiomer. Okay? But a lot of organic compounds have enantiomer, a mirror image substance. The reverse or the opposite. Things like that. Okay? Muna siyang mga enantiomers. You get the point? So these are small terminologies that you have to understand also. Actually, this is a mixture already of chemistry and general chemistry and organic chemistry already. A little bit, okay? Things like that. Okay. So any questions so far with our science topic for today? So I hope you like it. You can comment down below the comment section. Okay, and then you can subscribe my YT channel. And then you can access me through also my 2 FB accounts, other social media accounts like that. And then you can also subscribe my other YT channel. My other YT channel is not monetized yet. That's only for exclusive singing. Okay, and then I will be very ecstatic and very happy if you can subscribe my YT channel. And I will be very grateful to the rest of my life. Thank you so much. Then you can also drop a message in my FB Messenger if you think that you are trying to learn something also with other science topics, as long as it's related to science. I will try my very, very best. Okay? Then thank you so much for your time to spend it with me, things like that, and bye-bye. God bless everybody. Remember this, that Jesus loves us. Bye-bye. Happy Sunday to each and every one of us. All parts of the world, wherever you are. Baboosh. Diba?